Unit 2 is about the atom, so you need to know the timeline of the atom from the foldable that we made in class. The modern atomic theory is based on Dalton's atomic theory, which we listed in our foldable. There was 2 exceptions to the modern that Dalton put down, and that's atoms of the same element may have different masses because of our isotopes, but they will always have the same the same atomic number because that's the number of protons. So that was his first mistake. His second one was that atoms can be subdivided, and we know that is, or he said they can't be subdivided. We know that they can be subdivided now because of nuclear fission. There are 3 laws of chemistry. The first one is the law of conservation of mass, and that just means the mass that you start with has to equal the mass that you end with. So if you start with 10 grams of reactants, you have to end with 10 grams of products. It doesn't matter that they're not the same substance. The law of definite proportions just says that our atoms will bond completely. You can't have part of an atom in a bond. So our ratios are always whole numbers. The law of multiple proportions means you can take 2 elements and you can have different ratios. So carbon to hydrogen 1 to 3, or 1 to 4, or 2 to 5. The atom is the basic unit that can enter into a chemical combination. It's made up of 3 particles: the electron, that has a mass of 0 and a negative charge, and is located in the electron cloud. The neutron, which has a mass of 1, is neutral and in the nucleus. So the neutral neutron in the nucleus. The proton has a mass of 1, is positive, and also found in the nucleus. So both particles that have mass are found in the nucleus. So the nucleus is the place in the atom that has mass. Atoms are electrically neutral. So unless there is a charge told to you, our protons equal electrons, so that the positive and negative cancel out. Atoms of one element have the same number of protons. It's called the atomic number, and that atomic number is on the periodic table. The atomic number is always a whole number because you can't have part of a proton. Atoms of one element can have different masses because they have different neutrons, and that's called an isotope. So if we take the number of protons and the number of neutrons, both of those particles having mass, and add them together, then we get the mass number. The mass number is for a particular atom, not an element. So the mass number is not on the periodic table. It has to be given to you. There's 2 ways that it could be given to you. If you have an element symbol and a number in the upper left-hand corner, that's the mass number. Or if you have a symbol followed by a dash and a number, that's the mass number. The nucleus is not a particle. It's just a very small, positively charged grouping of protons and neutrons. And because the protons and neutrons are the only particles that have mass, it contains the mass of the atom. Alright, so how many protons, electrons, and neutrons do these 3 isotopes have? Neon, 20. So this is my mass number. My element is neon. So if I look on the periodic table, I know that the protons are 10 because neon is number 10 on the periodic table. There's no charge. So if we look at our symbol, the upper right-hand corner is where there would be a charge if there was a charge. There's no charge given to us up there. So the electrons have to also be 10. For neutrons, we have to take our mass number minus our protons to get our neutrons. So it would be 10. Okay, so up here in the upper left-hand corner is my mass number. There's nothing in the upper right-hand corner, so there's no charge. So it's neutral. Uranium is number 92 on the periodic table. So we have 92 protons. Because it's neutral, we also have 92 electrons. So to figure out our number of neutrons, we take our mass number, 234, minus our protons, and we would have 142. Okay, again, in the upper right-hand corner, we have our mass number. The number, if given to you in the bottom right-hand corner, left-hand corner, is actually your atomic number. So anytime they give you that number in the bottom left, you actually don't need a periodic table. They're telling you what the atomic number is. So for protons, we would have 8. There's no charge, so the electrons would also be 8. For neutrons, we would say 18 minus 8 to get our 10 neutrons. Again, your isotopic symbols. You have the mass number and the atomic number. This should be an A. So you have the element, and then you have the mass number. A charge is shown in the upper right-hand corner. If it's a positive charge, it's telling you you have more protons because protons are positive. If it's a negative charge, then you have more of the negative particle, the electron. So how many protons, electrons, and neutrons do we have in these? Protons, you have to look at the periodic table. Bromine is number 35. There's a negative charge this time. It's negative, so I have more electrons. I have one more electron, negative electron. So that means I actually have 36 electrons. For neutrons, we're going to take our mass number, 78, and we're going to subtract our atomic number, or our number of protons, 35, and we get 43 neutrons. Here's our charge. Here's our mass number. Protons. I look on the periodic table for sodium, and sodium is number 11. It has a +1 charge. That means I have one more proton than electrons. But if I take away a proton from here and make it 10, it's not sodium anymore, it's neon. So instead, we're going to just remove an electron. So I have one more positive than I do negative. For neutrons, we're going to take our mass number, 24, subtract our atomic number, and we would have 13. Mass number, charge. Again, I need to have two more protons than electrons because it's positive. Because it's calcium, I look on the periodic table, and my number of protons is 20. The electrons, I need two more protons, two more positives, than negatives. That means I have 18 negative. For neutrons, 41 minus 20 would give us 21. Charge, mass number. The negative tells me I have 3 more electrons than protons. For protons, I look on the periodic table, and phosphorus is number 15. So if I need to have 3 more negatives, then I would have 18 electrons. For neutrons, I would take 32 minus 15, and that would give me 17 neutrons. Mass. The relative atomic mass is based on carbon-12. In an element carbon-12, or the isotope carbon-12, we have 6 protons and 6 neutrons, so it's an even match. That's why it's based on it. Carbon-12 has a mass of 12 AMU. The average atomic mass is the average of all natural isotopes. That's the average that's on the periodic table. So the mass that's on the periodic table is the average of all the isotopes put together.